Yeah, okay, so everyone, welcome to this info session about new upcoming Math Quantum Fellowships. We're just gonna get started, but I guess first I will introduce myself and allow Constantino to do so as well. My name is Daniel Serrano. I am employed here at the University of Maryland, where I've been for a few years already, worked on putting together programs like this one. So programs that are intended to bring to the undergrads and grad students at the University of Maryland opportunities to expand their careers, to kind of like explore interesting, new, engaging topics similar to this one, which is dealing with quantum.
Yes, my name is Constantino. I am an applied mathematician and the director of the Institute for Physical Science and Technology. I'm the planner of this project. We are all very excited to welcome you and very excited for your interest. My area of research is fluid dynamics, analysis, numerics, simulation, then construction of quantum algorithms, and everything in between. And I would like to invite Carl Miller, who is another co-PI of the project, to introduce himself.
So I'm Carl Miller. I am a fellow at FIX, which is in the next building, and also a mathematician at NIST. And I did a career transition long while back from pure mathematics into quantum, and it is neat to see the beginning of a structured program that kind of reflects that combination.
And for those of you in the back, don't be shy about moving forward. We won't feel interrupted if you do want to sit down. It's okay if you want to stand like that. Okay, so let's get started. We want to begin by giving you just a general idea of what this Math Quantum thing is outside of the context of the fellowships, and then we're going to deep dive into the fellowships themselves. But this program is something that's beyond the fellowship, so we want you to understand the context a little bit. So this Math Quantum program is called an RTG. That stands for a research training group. And the idea is that we're bringing together scientists across different stages of their career to do research in quantum. So we're funded by the National Science Foundation for at least 5 years. And the main goal that we have with Math Quantum is to bring more mathematicians and bring mathematics further into the realm of quantum information science, and also to develop advancements in mathematics itself by drawing from the challenges that are presented by quantum information science. So the implication here that I want you to kind of get out of this is that for someone to join Math Quantum, there's no expected background in quantum. And actually, we might embrace a lack of background in quantum because that might give us a little bit of like sort of like diverse insight into how we can tackle quantum problems. So the program itself kind of conceptually is built under two branches. One of them is the research program and the other one is the education program. So the research program, the intention there is to bring mathematical techniques and tools like nonlinear analysis, partial differential equations, etc., and cross them with 3 core quantum areas: algorithms, cryptography, and systems. And so to do research within the intersection of those two parts. And then the education program is intended to bring mentoring education, teaching and professional experience, and community building activities in order to both merge into what we call a vertically integrated research group. So vertically integrated means that all the members of the research group contribute meaningfully and interact organically, meaning that in some kind of like more conventional arrangements, you might have like an undergrad student that's being mentored by a grad student and not really interacting with the faculty member too much, or different sort of like secluded ways of interacting. But the vertical integration is intended for everyone to interact with each other. And so the idea is that these two things blend, and the vertically integrated research training groups will be doing awesome research that advances mathematics by solving few quantum information science questions, and that we will prepare undergrads, grad students, postdocs, and faculty to be able to advance their careers in the context of math and quantum. So now we're going to go over some of that research part that I mentioned, the green arrow.
Yes, I just want to say a few words in order to pick your brain and to get an idea of what this program is all about. It is a really exciting period for the field of quantum information science. with many advances in the theoretical component and in the practical aspects. We have the construction of new efficient quantum algorithms that can speed up computationally significant in comparison with classical computers. So in this, the speed up can, in some cases, be exponentially and exponentially speed up. So we're going to speak about the hardware also in this course, in this program in general. And there are more and more new hardware that can handle more and more qubits, quantum bits. And so all of this will be accessible to you through this program. So we are going to focus on 3 research areas. The first is quantum algorithms. Quantum algorithms investigate what I already said, the possibility of solving computational problems dramatically faster with computers that store and process information quantum mechanically. So this the idea behind this sort of computation is that we want to do computation based that are grounded in physics. So of central importance in this particular domain is the so-called error correction, because when the first systems were constructed and the first algorithms were built, everybody thought, oh, can these computations be really robust? And the quantum systems seem to be very fragile. Well, it is the field of and advances of the field of error corrections that gave a big boost into the field of quantum algorithms. So what kind of applications can you imagine here? Drug discovery, drug delivery can be applications connected with quantum algorithms. The design of new material can be an application connected to quantum algorithms. Whatever physically relevant engineering application will benefit greatly by advances in quantum algorithms. So which question is very important here? And for us, because I believe that many of you, like me, are in applied mathematics or in mathematics, the question is which mathematical fields can move the field forward? Well, analysis is of great interest, scientific computation, differential equations, partial differential equations, probability, statistics, stochastic processes. I can imagine even algebraic geometry. Our colleague in Wix, Alagic, who is a member of this RTG, is a pure mathematician working on algebraic geometry, and he has contributed greatly in the field of quantum algorithms. So let's go to the next area that will be of interest is the area of quantum cryptography. So when you speak about cryptography, cryptography investigates the interactive information processes in scenarios where not all parties are trusted. So you have the prisoner's dilemma, for instance. So there are some very famous game theory examples that are connected to this topic. So what about quantum cryptography? Quantum cryptography explores the unique properties of quantum devices to secure information. So this particular area has great applications in cybersecurity, national security, anything that has to do with communication and ensuring secure communication is related to the area of quantum cryptography. So what mathematical fields can move the field forward? And actually, Carl Miller is more appropriate person to describe this. Algebra, algebraic geometry, model theory, analysis. What are you saying?
One example is complex analysis, and I'm going to actually talk about that in October. There was this unexpected application of complex analysis to coin flipping. So, yeah.
Thank you. So the third area of interest is quantum systems. This area is very broad. So quantum system investigates quantum phenomena that appear in various systems. So you can imagine that this particular research area has a lot of applications, particularly in engineering and in technology. Here we mention only some areas that will be part of certain discussion that we're going to lead throughout the program that involves rare events in quantum chemical systems. Quantum chemistry is a very important field, and some people believe that this will be one day the killer app will be in connection with quantum chemistry and quantum oscillators. So these applications are mainly engineering applications that you're going to see through this area of research area. So which mathematical fields can move the field forward here? As before, everything is possible. Analysis, scientific computing, differential equations, probabilities, stochastic processes, statistics can be of great asset that can make major contributions in pushing the field of quantum systems forward. So, and I would like to pass
And yeah, I saw that a few new people come in. Definitely, this is an informal setting. Feel free to just come in and sit in the front if you want to. It's okay if you want to stand, but we won't feel interrupted if you just move to the front. But I will move on to the next part. So before really getting deep into telling you about the fellowship themselves, I want to advertise our fall event series. So I see that some of you already picked up printouts of the poster that we have put up together for these events. But I also wanted to make you aware that MathQuantum.umb.edu/event will have a listing of these. I want to go there now and show you, kind of guide you a little bit through them so that you get a sense of what we have in mind. So the idea is that we're going to have a series of different types of events. So we're gonna be having lectures. These are more on the educational side of things. So this includes something that we're titling A Gentle Introduction to Quantum Computing for Mathematicians. That will be part 1 and part 2. So these are intended to, as the title says, we are not expecting people to know about quantum computing, but if you're in math and you're interested in learning more about the field and how they connect, this is a place for you to come. We're gonna have 2 film watchings and followed by discussion. These are one in October and one in December. And basically, we're gonna be watching a couple of documentaries about quantum computing, and then have some conversation and ability to interact with each other and get to know, others at UMD that are interested in these topics. We're gonna have a workshop that I'm gonna talk about in a little bit more detail in my slides, so I'll skip that. And then we're gonna have a couple of panels and seminars that are going to give you an insight about the actual applications of mathematics to quantum information science. So this includes a panel by people that have gone through the process of starting as mathematicians without a background in quantum and then getting into the field without a support such as this internship. They kind of like maybe did it a little bit on their own, and they're gonna tell us about how that process was. And then another panel where we're gonna have people from industry talking about how math is being applied to quantum information science outside of the academic setting. So let me get back to the slides to tell you more specifically about a couple of events. The first one is the workshop that I mentioned. This is a workshop that is intended for you to sort of come with your existing interests, skills, and knowledge in maybe physics, mathematics, computer science, but possibly not really understanding how they connect to quantum. And we're gonna guide you through, kind of like give you a little bit of an overview of those connections, and then there will be some exercises and interactive activities for you to discover how your current knowledge relates to QIS, what potential connection you have with QIS, and what potential contributions you could have to QIS. So this is particularly intended and being designed for graduate students and postdocs, but if you're an undergrad and you think this fits with you, we also invite you to come. Then the second event that I want to advertise is this Quantum Information RIT, which stands for Research Interaction Team. It's going to happen every other Thursday, starting on the 12th of October at 1 p.m. Basically, there will be 6 lectures on the fundamentals of how math connects to quantum information science, and then the remaining of the semester we might dedicate to some talks by the participants themselves. You could earn a credit optionally if you want to, and we can give you more details about what the requirements would be to earn a credit. But if you're interested, we're not giving a lot of details, but if this sounds generally interesting to you, you can just contact me directly and we can give you all the information for you to join. I don't know if either of you wanted to add anything about the RIT.
Yeah, so just to say, so Daniel previously showed the list of these broadly accessible talks, which are about the field broadly. And then the goal of the RIT is to have a more technical focus where we start to get more deeply into the math. And the lecture I'm going to give on 10-12 is sort of to guide us in that split. So we'll have the broader stuff and then more technical stuff in parallel.
And this is sort of like, unless you're signing up for 1 credit, I think we are sort of open for you to come and give it a try and see like whether or not it's something for you. So definitely, if it even sparks your interest, feel free to contact me and I'll give you all the info so you can join and leave the first session. Okay, so the fellowship, right? This is what we're all here for. So the idea is that undergraduate students and postdoc fellows will be contributing to that research program that we presented and will be benefiting from the education program that we're putting together. That's sort of like the main idea here with the fellowship program. Who fits in the program? So we're basically looking at 2 populations. And by the way, at this point of the talk, I think this is where I'm going to start providing information, and it's very much that it might sort of like bring some questions into your mind. Feel free to raise your hand, interrupt me, and then I'm happy to answer. And by the way, feel free to come in if you want to take a seat. It's okay if you want to stand there. So 2 main populations that we're sort of like thinking are a good fit for our program. Although others are welcome as well. We're happy to talk to you and see if you are like someone that if you don't fit these categories, we're happy to talk to you and see if it's like a good fit for you. But basically, it would be current math students that have little or no experience in quantum information science, but want to enter this research area. And then current students that have moderate or high experience in quantum information science, but they think they might be able to enhance whatever it is they're doing right now by having growing their math skills or by implementing more advanced mathematical tools into their research. So who is eligible for the fellowship? I'm going to go through all the 3 categories. So for undergrads, you have to be a UMD undergrad if you want to participate in the fall or the spring. There's also a summer fellowship, and I mean, I think everyone here is probably from UMD, but just to make you aware, there's a summer fellowship where fellows can come from any school across the country. You can be any standing, first year, second year, fourth year, anything after that. And then you can be any major, but we will be prioritizing math, physics, computer science, and electrical and computer engineering. For the grad students, a current grad student or an undergrad interested in grad school at UMD. So if you're an undergrad here at UMD right now, and maybe you're sort of like in the later stages of your undergrad, you're like thinking, maybe I want to go to grad school. This is also for you. This is the grad fellowship is something you could apply as you're applying to UMD graduate school. So that's something you don't have to be a grad student currently to apply for this one. The requirement in terms of timing is that you need enough time before graduating to complete the different fellowship requirements that we have, and I will talk about these. But of course, we're willing to talk one-on-one with you to see if it's possible for you to sort of like waive some sort of requirement experience that you've already had. And then you can be from any program, but of course, we will be prioritizing applied math, physics, CS, and ECU students. Finally, for the postdoc fellowship, which similar to the grad fellowship, you don't have to be someone that already is a postdoc or something like that. We expect you to be either hold a PhD or be a grad student that is close to graduating. So again, if you're a grad student here at UMD and you're going to be graduating soon, and you might be interested in continuing some of the stuff you're doing here, or maybe shifting over to quantum, you can apply for the postdoc fellowship. And you can, any PhD degree type of degree, except we will prioritize the same areas. So we do want to be transparent about this. The funding agency that's giving us the money for this fellowship has a restriction that we can currently not offer the stipends to you. We can only offer the stipends to US citizens and permanent residents, while those who are not citizens or permanent residents can become fellows. You can still apply and you can receive all the benefits, but we are not able to provide the stipend side of it. And you'll see what that represents in a little. So what are those financial benefits I mentioned? So for the undergrads, we're expecting to be able to take 6 undergrads per year for the duration of each of those 5 years that I mentioned. You're expected to participate in the fellowship if you are accepted for 1 term, meaning like 1 fall, 1 spring, or 1 summer. But you are also able to renew it if you're like, you're enjoying the program, you can apply for another term. What we will provide is for the summer fellows, $50 to $100 of stipend, plus housing at UMD, plus if you're coming from outside of UMD, travel to the university. And this would be for a program that lasts 8 weeks. And then for the fellows participating in fall or spring, you would receive a stipend of $2,500. And the time commitment would be arranged sort of like appropriately to this level of pay. And then you would also be receiving $1,000 of travel to go and do professional travel. So go to a conference and things like that. Okay. So grad students, we expect to be able to take 5 per year. And then you would be participating if you get the fellowship for 1 year. And similar to the undergrad, you would be able to apply again for another year if you're enjoying the program. So you would be receiving 37,000 stipend plus tuition per year. And then you would also receive that $1,000 for travel to conferences. And then finally, postdocs, we expect to be able to hire 3 of them total. And then this would, your commitment would be a minimum of 1 year, a maximum of 3 years. And then the pay would be between $65,000 and $70,000 per year plus benefits. And you would receive $6,000 for professional travel. Okay, so again, repeating that due to funding restrictions, we can only offer the stipend part. This part, we can only offer it to U.S. citizens or permanent residents. The travel and everything that I'm going to talk about in the next slides is something that a non-U.S. person could join the fellowship and benefit from. So what are the educational benefits in addition to those financial ones? You would receive one-on-one regular career planning. So Constantina and I are going to be meeting with each fellow that joins once they join the fellowship and regularly over time to create a career plan and see how you are interested in following up with those plans and how they evolve over time. We will be offering a series of professional development workshops, which are 1 per month, and I will talk a little bit in more detail about those in a slide in a second. We will be partnering with industry and government to offer internships in case that you're interested in exploring those environments while you are doing your undergrad or grad school. You would, of course, this is kind of like one of the core things, you would be working with the faculty and the rest of the members of the RTG to have a research project that's intersecting mathematics with quantum information science. We are going to hold a bunch of different community building types of activities. I'm going to mention a few of them in a little bit. And then we will be offering a series of quantum courses that you would participate in. These are not restricted to fellows, but of course, if there's any seat capacity limits, the fellows would have priority for those. And then the courses will be a course in the fall that's going to present to mathematicians what is the mathematical basis behind quantum information science. A spring course that would then take that theory that you learn and see how it can be applied for actual quantum information science problems. And then in the fall and the spring, we would offer a 1-credit seminar that's kind of similar to the RIT that we mentioned, that we described, possibly with a little bit less of the lectures and more with participation and focusing more on cutting edge research that's happening right now at the intersection of math and quantum. And then, okay, so there's more benefits. So we are going to hold a summer proposal writing school every year, where we're going to teach you how to write research proposals. Basically, it's like an intensive kind of thing where we expect that at the end of it, you will actually have written a draft of a real proposal that you are able to submit. So, let's say for grad students, it could be a fellowship proposal to get even more funding after this one. For undergrads, it could be like applications to grad school, applications for jobs, where you have to maybe write a research statement or something like that. And then we also will be holding a workshop in the winter, talking about the societal impacts of quantum information science and helping you discover how you are interested in engaging with outside of the academic setting or the research setting with kind of like the broader society in terms of your contribution to QIS. And then you will also have some leadership experience, so that I can talk in more detail about that with you one-on-one if you're interested in learning more about it, but it involves sort of like building your leadership skills. Right, so these are the fellowship components, kind of like all in one page, and I know that it might be a little bit overwhelming. It's everything that we're offering to the fellows, basically. And sort of like at the same time the requirements. What I do want to emphasize is that this is a timetable just compressed into 1 year, but of course, if you become a fellow, you would not be required to complete all of these things within 1 year. It can be sort of like spread out, and you can do one course in 1 year, the other course in another one, etc. But I do want to go through these maybe a little bit quicker than I originally intended, but so we split into categories. The first one is mentoring. So of course, as I mentioned, you would be working with a mentor on a MathQuantum research project. You would receive one-on-one support. So these meetings that you would have about your career development. Then the quantum education is it involves some of the things that I already described: the RIT, the theory course, the workshop on societal impact, the applications course, and then the proposal writing school. The professional experience would involve, so this is something I haven't mentioned, but our fellows will be expected to, the grad and postdoc fellows will be expected to do some teaching. And so that's why we mentioned that here. So like TAing. And then, opportunities to do internships with industry and government, and then the monthly professional development workshops that I mentioned. And then the community building will involve a set of activities spread out throughout the year. So I have a slide in a little bit to tell you some more about those. So just to give you a little bit of a sense of what we're thinking about with these professional development workshops, again, we expect to do about one per month. The topics will be chosen by getting input from the fellows, so that we kind of like are giving you what you actually are interested in hearing about, but also kind of like getting some insight about what math and quantum employers are looking for, what skills they need, that they're like interested in having people build, so that we really are giving you professional development that is relevant. Some examples would be, things like how to build a personal and professional web page, workshops on CV resumes on LinkedIn, the ethics of QIS, how to tackle imposter syndrome, how to do mentoring, especially across diversity, how to find jobs in different sectors, how to apply for jobs, workshops on interview skills, things like visual communication, how to like express your research through visuals and illustration. So those are just some examples. And then in terms of the community building, so we have a few of these listed here. There's going to be a graduate student-led event. So this will allow the grad student fellows to come up with ideas about some event that they want to host. Like, let's say it could be a hackathon, it could be like industry, like professional, like career workshop or something like that. And then we would help them go through the process of actually planning this event. There's a vertical integration workshop where we're going to bring together all of the RTG members, so the undergrads, grad students, postdocs, and faculty. And we're going to be talking about what it means to be in a vertically integrated group. And then we're going to like actually put together vertically integrated research projects that really take the skills and the interests of all of the different members of the group in a way that is cohesive and contributes to the MathQuantum vision. We're going to have an annual symposium, which is pretty straightforward to explain. It's like a conference, basically, a mini conference for all the fellows to present their research, posters, oral presentations, etc. And then some of you might be familiar with Maryland Day. So this is an event that UMB holds where like thousands of people, I think like tens of thousands of people come from the community, come to UMD to learn about like everything that's happening at the university. And we plan to have a booth for MathQuantum every year. And so then the fellows would be contributing with ideas and volunteering to actually run these events. So what are the requirements? And by the way, questions at this point or? We're good. So what are the requirements? I gave you all the components, but of course you're not expected to do them all in 1 year, and there are differences between what you have to do depending on your standing. But these are the main requirements. Of course, the main one, which is expected from everyone, is to engage in a MathQuantum research project with a mentor. The professional development workshops that we're offering, we would expect undergrads to participate in at least one total. Grad students to participate in at least 2 total, and postdocs to participate in at least 2 total. But of course, if you want to go to all of them, that would be better. Participate once in this societal impact workshop. Participate once in the proposal writing summer school. For the grad students, they would be expected to TA for 2 semesters, and the postdocs would be expected to teach 1 class per semester while they're in the part of the fellowship. Grad students and postdocs, because we are really emphasizing this idea of vertical integration and interaction across the different levels, then they are expected to mentor either undergrads or newer grad students. And then attending the community events that I mentioned. Obviously, we would work with each fellow to assess their level of commitment for each of those. And then participate once in the Maryland Day outreach. So previous experience may come to our requirements. So if you're already TA, we're going to work with you and determine what you did, and then sort of check out the list to minimize their redundancy of requirements. Okay, so what goes into the application? So if you're interested in learning all the details, you can go to mathquantum.umd.edu/apply. But it's pretty straightforward. So there's a Google form that asks for some basic information from you. Everyone is expected to fill out a form. There's a form for each category, and you will see it specifically linked on the page, depending on who you are. We expect for you to give us a statement of why you're interested in joining MathQuantum. So kind of explaining, where you're coming from math, or where you're coming from quantum, and how do you want these 2 things, or how do you think these 2 intersect, or why you're interested in exploring those intersections. 1 page maximum. It can be less than a page. A statement of research goals, and that would be 2 pages maximum. There's specific nuances to what we're asking for each of those categories. So just read on the actual application form. It'll tell you specifically what we are looking for. Because we don't expect undergraduates to have as much experience in some of these topics, so we're asking for a little bit different type of information. A CV, which actually there's a mistake here. The undergrads are not expected to submit a CV. The grad students and postdocs are. And then letters of recommendation. So we would expect 1 minimum from the undergrads, 1 minimum for the grad students, although highly encouraged to submit 2, and then 3 for the postdoc applications. Pictures. So we do want to emphasize that you don't need to have a mentor or PhD advisor when you're applying. If you're an earlier on grad student and you're still working that out, we still invite you to apply. What we would do, you can continue searching for a mentor and through the process that your department has for you to kind of do that part of your graduate career. But we would also get the information from you and then decide have a conversation about whether one of the RTG mentors would be suitable and available to become your mentor. So we would kind of work with you and figure things out as best as possible. So we don't discourage you from applying if you don't already have a PhD advisor. And it's also okay if you have an existing mentor that is not part of MathQuantum, and even they might not be working on quantum information science or something like that. As long as they approve that you join the fellowship, and they actually might be interested in sort of having a grad student that they're mentoring join the RTG as a motivation for them to kind of explore some areas of quantum. So that's okay as well. If you have more specific questions about this, we're definitely happy to talk about that. Okay. So what are the deadlines? Undergraduates and graduates wanting to join in spring of 2024, we have a deadline of December 8th. Undergraduates interested in the summer program, we have a deadline of February 16. And then if you're interested in the postdoc, it's rolling, there's no deadline, because this is more like an employee kind of situation. Right? That's it. So at this point, I'm going to open the floor for questions. I also want to know that we have an event feedback survey. There's a QR code and a short link there if you are willing to give us some feedback on our event. But with that, I'll just, any questions, I'll be happy to answer them.